Data Skeptic is the official podcast of dataskeptic.com, bringing you stories, interviews, and mini episodes on topics in data science, machine learning, statistics, and artificial intelligence.
Joseph Sirosh is the corporate vice president for the data group at Microsoft, where he leads the company's database, big data, and machine learning products. Joseph holds a PhD in computer science from the University of Texas at Austin and a bachelor's in computer science and engineering from the Indian Institute of Technology, Chennai. He is passionate about machine learning and its applications, and one of his missions at Microsoft is to democratize ML technologies and make them accessible to everybody. I had a chance to sync up with Joseph about some of the recent announcements coming out of Microsoft Ignite. Maybe to begin with, could you highlight some of your favorites?
Yeah, it was an exciting conference, and we announced a great AI platform for the advanced developer so that you can build even the hardest, most tier one, big scale AI and deploy it effectively. And so for the pro developer of AI, we have what I think is one of the best platforms, easiest. It makes a lot of very scale AI possible. So that was one thing. Then we talked about how you can interface all of that AI with applications like Excel, which is potentially very interesting, with things like ArcGIS for geo AI, like geographical information systems. Then we talked about some powerful concepts around cognitive services and the bot framework. The bot revolution continues on. I think those are some of the most interesting ones in my mind.
One of the things I'm most excited to get my hands on now is the debut of Azure ML Workbench.
Yeah.
For those who didn't catch your keynote or some of the details, could you give us the high level on what that tool suite is?
Yeah, absolutely. Happy to. And by the way, there's a full recording of my keynote on YouTube available already, Microsoft AI Platform, if you search by name. So let me cover Azure Machine Learning. We launched 3 major new features. Workbench, which is a client that integrates AI-powered data wrangling into the client itself. So that allows you to really transform data with the power of AI. And I'll tell you more about that in a minute. So that's a cool one. Then we launched an experimentation service on the cloud that allows data scientists to really track and manage their big data experiments on Spark and GPUs and all of that, and use all the power of the cloud to scale out these experiments, but also version control them, to track them, to manage them, and understand all the run history and so on, right? And that's very powerful. And then we announced also Azure Machine Learning's model management, which is really about once you built a model, deploying it to Docker containers, for example, and then monitoring it, right? Managing the versions of the deployed model, getting the telemetry from that, monitoring it, being able to update it when necessary. And so not just even on a cloud, but on the edge and on premises if you chose to, or other clouds. So 3 things. So then let's just talk about Workbench, for example. We integrated a technology called program synthesis by example for data wrangling. So what does that mean? Look, data wrangling is where people spend 80% of their time cleaning data, transforming data, shaping it, cutting, pasting pieces so that you can actually extract the input variables to a machine learning model. You can define the target, all of those kind of things. So, we asked the question, can we make that a lot easier by removing the painful coding required to do these things reliably, right, over large data? So the answer to that was program synthesis. And we had a great technology in Microsoft research around program synthesis by example. And the way it works is, you give an input data, the kind of data that you want to wrangle, and the output you want it transformed to. So you can show the before and after. And then the program synthesis technique will generate the program for that data transformation automatically for you. And you can run that on all the data, and you can verify that it works. And if there are examples where it doesn't work, then you give more corrective examples, and it will regenerate a program that fits it better. And the power of this is now you've got a program that you can now take out, stands alone, stands independently of everything else. else. You can run it on a Spark system at big data scale, or you can run it anywhere you choose. So you've written a data transformation program completely automatically. And that kind of technology, I think, is really, truly transformative. And that's going to make, it's so much easier for people to go from data to the final model and driving business processes much, much faster.
Yeah, the program synthesis by example was a pretty striking demo for me. I know I've spent a lot of time in my career, splitting a string by underscore, then taking the second element and lowercasing it and all this sorts of craziness. It's obviously doable, but it's rather tedious. Do you have any maybe rough stats on how much time savings can be enabled by the program synthesis technologies?
It depends on the complexity, obviously, or the kind of transformations you're doing. So if you're doing like log processing and deriving variables out of it, or from text data, etc., now this kind of stuff can save 80%, 90% of time that you would otherwise spend in just that kind of code writing for dirty data. That's very, very powerful, right? And we're just getting started in this area. Now, obviously, program synthesis doesn't get you to derive variables for machine learning models. It is ahead of that process, which is about cleaning data. And in a lot of finance applications, log analytics applications, and crunching all kinds of data collected by surveys and marketing interactions and customer call center data, things like that, the savings here are enormous.
Absolutely. So moving on to the Experimentation Service, this is something that really caught my attention as well. I mean, anyone who does any development knows about GitHub and how to do version control on software. But of course, machine learning models aren't software. They're the result of some script. And there never has, in my opinion, been a good way to track these and manage them and maintain them over time. What does the Experimentation Service give for someone that struggles with issues like that?
Yeah, I think so. We are leveraging these same tools like GitHub and others, and now it's bringing that to machine learning, right? So what machine learning, if you think about machine learning, there are like about at least two artifacts there, maybe three. The code itself to generate the machine learning model, then the model itself, the data transformations and the model, and then associated with that, the data sets you use to derive the model. So there are like sort of three artifacts. Turns out you can manage all these three artifacts using the version control tools that we have. So we used Visual Studio Tools, VSTS, the Git. We used all of those capabilities that are already available for software developers on Azure and layered all of those capabilities on top of machine learning. And then we gave people the ability to record the run history of every experiment you ran. So whenever you run an experiment, all the parameters of that are recorded in a database. And then you can browse it, you can compare, you can have plots on it, you can see which experiment with what parameters worked the best. You can choose that, so on. So just again, using all of the infrastructure available for software development and databases, etc. we have on Azure to just ensure your experiments are treated as first-class version systems that you can track. And that's very helpful, especially in a large enterprise setting, right? And you're as a team developing lots of models, you're experimenting, having it all be organized and also being able to share these and collaborate. I mean, all of those things are super critical for tier one ML development. And one more thing Experimentation Service allows you to do is a runtime environment. I mean, you can run it on Spark clusters, you can run it on GPU VMs. We can even use Azure Batch AI training for it. All of that is linked in. And so what kind of service on Azure you use and how you manage that, all of that is supported in the Experimentation Service.
Very cool. I've done a lot of experiments like that in a rather manual way in my career. I've maybe wanted to do some parameter tuning or test different subsets of features into a model. And what I've always kind of historically done is felt like a hack. I kind of write some results like the accuracy and whatnot to a text file, and then I have to write a bunch of custom code to compare the various runs, and also have to be very careful to track, what I ran before and these sorts of things. What's the experience going to be like in the future for someone using Experimentation Service? How do I get to compare my models in an elegant fashion?
Well, if you use Workbench now, Experimentation Service is sort of connected into the Workbench. All the Workbench is a thin client. Experimentation Service runs in the cloud. All of the model performance, the model parameters, a lot of that is really surfaced in the nice GUI interface that we have. And so now, instead of poking around directories where you have got these different experiments, I mean, all of that is something that you get reports on in that Workbench. And then if you choose to, you can also have command line interface to just type commands to bring up certain versions of certain experiments, look at their parameters, and so on. So you can interact with the system either from a command line tool or from the GUI. So now it becomes a well-managed surface area.
Let's perhaps talk about the model management lifecycle. What that has meant for me and a lot of models I've built is, I finally come up with the model I like from some hacky experimentation process, and then I'm stuck with this thing that, just sort of a binary object in memory, and I have to figure out a way to turn it into an API. What are some of the new advancements I can take advantage of?
Yeah, and that's where we've made a big step in that. We just Dockerize it. We package that whole model up, make it a Docker container. And then the Docker container comes with all the way, features to emit telemetry. You can make it an ML service very easily. It can be managed in Kubernetes clusters, so you can scale out serving of that model. So if you want an API in the cloud that just scales as more and more demands come in, it just scales very easily. Then you can integrate all of that with Azure Monitoring Service, so you know how it is working. You have App Insights, which you integrate into. You get the full telemetry around the application itself, so which means how is every record being scored, what is the performance of the model, how many transactions are happening, any number of these things, right? So you now have a full application that you can have live on the cloud. And like with one command, we can actually publish a model out of the experimentation service into a Docker container and have it live on the cloud. And that's very simple. So really, I want you to think about Azure Machine Learning as comprising three major things, right? AI-powered data wrangling in the Workbench, end-to-end machine learning dev productivity with the experimentation service and Spark and GPUs and all the open source toolkits. And third, deploy anywhere with Docker containers. You can deploy it on Spark, IoT Edge, on-premises, other clouds. And so you bring these three features, AI-powered data wrangling, ML productivity, and deploy anywhere. Now you have end-to-end tooling for AI development. So that's what you got.
That's excellent. Very end-to-end. I think that's the best way to put it. I had been working with one of my clients on a project, and we were using Azure ML Studio, which we liked quite a bit. It was really helpful to accelerate our model build time. But at least in this particular instance, we got to a point where it does obviously you can have RESTful APIs from your models there, but I think they're only available as Azure Lambda functions. And this particular client was very concerned about it being on-prem. So now that's no longer an issue. If I can get a Docker container, I can run it anywhere, on-prem or in the cloud, as maybe they grow to be more comfortable with the cloud. What's the relationship now between ML Studio and the Workbench project?
Yeah, it's a very good question. So think about this as the new launches as the pro tool set. So if you have a pro tier 1 customer who you really want to build sophisticated solutions for with a lot of choice, you really want to use the new pieces that we launched. If you are more like a customer who wants to have the very least amount of hassle building something on the cloud and deploying them as a REST API in the cloud, you use Azure ML Studio. So in many ways, this is a choice between, do you want simple ease of serverless development, whereas on the new collection, it's not really a serverless model we are going after. It is a server-based model, and of course, you can export Docker containers. So that's the difference between the two.
Makes sense. Yeah, and I could see I don't know if I want to put it as basic and advanced because that's not a completely accurate statement. There's still a good need for quick serverless design, but now that I have this container and I can launch it into Kubernetes and hand that over to maybe a engineering group that's better at managing that, it opens up the breadth which I guess we can put ML into different organizations.
Correct. And it is, of course, not just ML either, right? In the Docker container, you can package the entire application as well. And you can take that and integrate it into other applications. So it is all of that flexibility that an advanced developer or an independent software vendor, any of those folks would need.
Yeah, makes sense. So when you create a model, I guess maybe sometimes that's the end of the story for certain applications. But in general, once a model's launched, that's your V1. And especially with an application like, let's say, fraud detection, there's always going to be an adversarial component or model drift and things taking place. So I'm excited to maybe learn a little bit more about Azure monitoring services and how that can help a data scientist kind of continue to maintain and monitor that end-to-end process. Can you tell me a little bit about some of the telemetry I get?
Yeah, and sort of every input that goes into it and output is recorded, right? So we are tracking in production, the performance of every model, and you can then get aggregate statistics out of it, and then you can see if there is model drift. And also using model management, you can have multiple models in production. And if you choose to, you can have A/B testing going on live. And so all of these things get recorded. And as a result, then you have the ability to understand whether your model is degrading, which needs to be updated, in which case you just run the update through the same process and push it forward. So I think we really have created really a platform that manages that heavy lifting also.
And from more of a development perspective, we've already mentioned that we can work in Spark, but what are the supported languages and tools that are easy to integrate for someone that wants to adopt the machine learning workbench?
Well, so we created a very open environment, right? And so with Azure Machine Learning, you can use any of the popular deep neural network toolkits: Cognitive Toolkit, Caffe2, PyTorch, TensorFlow, Chainer, Scikit-learn, Spark MLlib, any of those. And you can actually run whatever runs on Spark, as well as you can use the data science virtual machine we have on Azure. So it's a virtual machine that's got all these tools configured into it. And you can also use the GPU virtual machines. So it's a very open environment that allows extensibility and use of your favorite tools. So what we've taken this approach of is, instead of taking a prescriptive point of view as to what tool you should use or limiting you in any way, we're essentially saying, hey, come one, come all. Today in this first step, by the way, we have really launched it with PySpark. So there is a Python as the primary glue language in all of these that we are working with. I think in future versions, you will see us integrate R into it and be even more open.
Makes sense. Yeah, I'm looking forward to that. I think most of my audience will be Python users, but there's certainly still a big R contingent, especially with the integrations of R and SQL Server. I know that's made R a very popular and accessible language in the Microsoft stack.
That's another one to connect with as well. So one of the big announcements this time was SQL Server's 2017 version, which integrates not just R, but Python as well. And so I can run deep learning models built with Python and TensorFlow, if I like, inside of SQL Server without the data ever leaving the SQL Server boundary, which means you get models running right next to the data with a lot of speed, models running within the compliance boundary of SQL Server. So it's actually very, very powerful.
Yeah, so having the models compute near the data obviously gives me some advantages and it cuts down on I/O. Could you talk a little bit more about the compliance advantage as well? That's something I hadn't considered.
Yeah, and this is a huge deal actually for a lot of enterprise customers. So SQL Server, the database management system, it's compliant in every environment, right? I mean, it's a product that's been out of the market for a long time. It's compliant. Because the data is never pulled out of that compliant database server, and the model is running inside the database server. So you inherit all the compliance, authentication, security, and everything that is in the database management system. And that's actually really important because in a lot of cases when people build and deploy AI applications, they're pulling data from databases out, and then the application has to be made more secure. You have to audit it, and there's a compliance requirement, all of that. Now, when you're pushing the model to where the data resides in the database, you inherit all of those benefits from the database management system.
Oh, that's wonderful. Yeah, I can see where that provides a lot of advantages to organizations that might otherwise not be able to adopt the tool.
But by the way, one more thing there is it's also a high availability, right? So these database management systems have always had really great capabilities for replication, for failover, for primaries and secondaries. So you get all of those benefits as well when you go deploy AI into a database management system. That's exciting. And then SQL Server 2017, by the way, is also on Linux. This is the first time ever Microsoft has actually deployed databases on Linux. So that's another exciting thing about the whole thing.
So one of the announcements that I found a bit surprising, but also very interesting and has got my curiosity and sort of my creativity running is this integration of Excel and some of the AI tools. Let's take a break from today's show to talk about our sponsor, Springboard. Springboard is a career accelerator that will connect you with a one-on-one mentor to help you advance your data science career. Your mentor might come from places like Uber, LinkedIn, Facebook, Amazon, and many other great companies. They'll not only help you navigate the data science curriculum that Springboard provides, but they'll also give you close mentorship and advice about how they launched their careers and got the roles they have today. Springboard has helped graduates get placed at companies like IBM, Google, Microsoft, Salesforce, Dropbox, Boeing, Nielsen, and many more. Springboard makes a guarantee on job placement. If you don't get a new position in 6 months, they'll give you your money back. That's how confident they are in their curriculum and their mentorship program. Learn more about Springboard by visiting the link I'm about to give you. It's SB for Springboard, sbdata.co/data-s-career. Your monthly cost could be as low as $27 a month, and they have financing options available. Find out if Springboard is right for you by visiting sbdata.co/data, the letter S, career, all lowercase, all one word, data S career. There'll be a link to that in the show notes as well. So one of the announcements that I found a bit surprising, but also very interesting and has got my curiosity and sort of my creativity running is this integration of Excel and some of the AI tools. Could you share some of what's been developed there?
Yeah, very exciting. Think about this. A vast amount of corporate data is actually in Excel spreadsheets, right? And finance departments all over the world use Excel as their primary data analysis and development platform. Now imagine being able to infuse AI into all of those spreadsheets. So imagine each enterprise and organization could come to Azure Machine Learning, build a model, right? An expert data scientist or a statistician would go build it on the cloud, and then deploy a web service that appears in an Excel spreadsheet just like a typical Excel function, okay? And so you can take a column or columns from the Excel spreadsheet, then type in equal to Azure ML dot some function name, and it'll just compute that AI model on those columns and return the result in another column. So you got a predictive column. And that's very, very powerful. And so I was able to show in the Ignite keynote a really great example where imagine you had satellite imagery of land in one column and associated URLs. And let's say you wanted to get the percentage of land that is forested and developed and how much is roads and all of those land features. I then showed how with a function in the cloud called classify land function, I could just go to a column and type equal to Azure ML dot classify land and then give the column number where the images were, let's say column A, and then out comes the percentage of the land in the image, that's roads, forested, development, etc. And then I can have Excel charts on it, and I can do further computations on it. So Excel suddenly got power to classify land. And that's all incredible power, right? I mean, the power leveraging the cloud brain, so to speak, in every Excel spreadsheet. So there's a future we are enabling for every enterprise on the planet that they can build their own custom AI in the cloud and deploy it only to their Excel users, right? And all the Excel spreadsheets of that company, can then leverage that power in the cloud.
Yeah, that was a really shocking kind of demonstration to me. I never expected to see Excel doing something quite so advanced.
Right. And think about this as a starting point, right? I mean, think about every Office 365 document eventually being able to just leverage AI in the cloud. So you can take pretty much any Office document, start with spreadsheets. That's where we're going to start because that's where it's going to be most useful. But then you connect that into the cloud and leverage this magnificent array of capabilities and compute that's available there.
Yeah. So I've worked with a lot of organizations where, as you said, tremendous amount of corporate data is stored in Excel. As surprising as that might be to a developer who's very comfortable working in databases, it still resides. Not only does a lot of the data reside in Excel, but people who aren't programmers and maybe don't know SQL but are still important analysts, often that is their tool du jour. And now I can perhaps provide them some of the services that might otherwise be REST APIs and microservices directly in their analysis platform. There was one phrase that kept being used in a couple of the demos was that it was whatever the data scientists or whomever makes available in that process. Could you talk a little bit about what it would take for me as a data scientist to expose one of the models that I think some of my colleagues would want to use in Excel to them?
Right. So what me as a data scientist would do is use my company's Azure subscription, sign up for Azure Machine Learning, build the model in Azure Machine Learning. Let's say it is a forecasting model or an image classification model. I just build it. And then there is a small number of steps to expose it in the catalog for Office 365. So in the Excel, when your users open up Excel, every one of the Excel spreadsheets that is opened up in the company will have a catalog in which the functions published in the Azure subscription are visible. And so then I just use it like an Excel function.
Very cool. So I was excited most of all, I think, personally by the announcements around Azure ML Workbench. As you said, it's sort of the first platform for data science that's really end-to-end. You can start from the data wrangling, and you even have the AI features to help there, all the way to very flexible deployment. I know some of those are new announcements, so probably some of the most maybe impressive use cases are being built as we speak, but can you speak to any maybe beta testers or early adopters who've taken advantage of those features?
Quite a few, and one particular one I wanted to highlight was this partnership we have with Esri. If you heard about Esri, Esri is the leader in geographical information systems. And you'll be amazed at how much of the world's data about properties, about roads, about structures, everything in a municipality, land records, all of these are stored in geographical information systems. Very powerful, very rich data that's relevant to all of us. And so we have this great partnership with them now to do Geo AI, where geographical information systems and AI are coming together so that you can take, for example, satellite imagery data and understand what's in it, right? You can classify every pixel of satellite imagery into, say, forests and roads and how the roads have changed and all of that in near real time. And so you can understand so much more about your land and property than you ever could. And then you can also, like, for example, use data. These geographical information systems have data around roads and intersections and all kinds of things. We showed an example where you could actually predict traffic accident probability in every part of the road using historical data that is saved. And so these are the kind of unique integrations. When you integrate a geographical information system with AI, the power of prediction that is now put at your fingertips, that's super exciting.
Absolutely. So what are you most excited for the applications of AI in the next, say, 1 to 5 years? What do you think is going to happen that is going to be new and impressive?
Well, I mean, personally, one of the most exciting things is its application in healthcare. So Epic, one of our partners, announced Epic Cognitive Computing Platform on Azure at the same time. And, you know, some of the examples are just amazing. For example, their data scientists have found that you can predict high blood pressure or hypertension up to 2 years in advance using electronic medical record data. So that's our data that, like, for example, if you use mychart.com and you go to a hospital, you're using Epic software, and they have all of my historical interaction, right, with the hospital. From that, you can actually predict, 2 years ahead, my whether I could get high blood pressure or hypertension. And that's just starting to scratch the surface of a lot of different things, which is very, very powerful. And then they're also able to, for example, look at data in the hospital and how doctors treat cases and find all the common use cases and shrink the time dramatically so that the doctors can take care of the common things like an earache or something in far shorter time, saving time for more complex cases. And these kind of applications are going to really revolutionize our health, indeed. In fact, population health management is going to be a completely different game in the next 5 years.
Yeah, it's very exciting. I've been keeping an eye on a lot of the advancements in the healthcare industry, and we've covered some on the show. The amazing things that machine learning, and particularly deep learning, has been able to help predict that is exceeding even doctor-level performance. So I'm totally with you on that, as healthcare being really one of the most interesting final frontiers here that we have. Well, we've covered a lot of great stuff, and I'll be sure to link to your keynote in the show notes so people can catch up on that if they missed it. For those listeners who want to really get their hands dirty, maybe try the Workbench out or see some of the data wrangling tools, the program synthesis by example, in a firsthand test it out on their data sets, where are the best places to go to get started?
Just go search for Azure Machine Learning. You'll find it on Azure page, and there is a very simple set of steps you can walk through to download the client to get going. A lot of information and documentation on Azure.com.
Excellent. Well, Joseph, thanks again for taking the time to come on the show and share some of your insights and some of the recent great announcements. I'm excited to get started with some of these tools myself and see what other people are using them for in the future.
Thank you very much.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.